Okay, welcome to the second video of 16.1 indefinite integrals. So, let me just put it this way. Okay, I do something simpler for you. If y is equals to 2x plus 3 to the power of 7, if I apply the chain rule, what I do is take the product of 7, the index, then you have 2x plus 3 power minus the index minus 1, 7 minus 1 is 6. Then you differentiate the 2x plus 3 to get a 2. Alright, so first we multiply by the index, then we minus 1 from index. Lastly, what we do is we differentiate and then we multiply the brackets, okay, which was the 2x plus 3. So if I do that in reverse order, okay, what I can do is to integrate, it will mean that I will differentiate the 2x plus 3, then I will divide, okay, then I will add 1 to index, then I will divide by index, divide by new index. So basically what I'm doing here is I am just doing the reverse order for integration itself. Alright, so now, okay, you don't need to worry so much about it. I will show you some examples. So for part A, it is this. If I integrate 2 minus 3x to the power of 4 with respect to x. So first I differentiate what's inside. Okay, 2 minus 3x. So 2 minus 3x, if I differentiate it, what I'll get is negative 3. So I just divide by negative 3 first. Then I need to increase my index by 1. So if I increase my index by 1, 4 plus 1 will give me 5. Then last part is to divide by my new index. So here is 5. Don't forget to add in my integration constant. So what I'll have here is 2 minus 3x to the power of 5 divided by negative 15 plus c. Okay, so this is for part A. Now, let's go on to part B. Okay, for part B itself, what I have here is, what I'm attempting to integrate is 1 over 3x plus 4 to the power of 4 with respect to x. So this, okay, I simplify or I change it to a form that's more useful to me, is 3x plus 4 to the power of negative 4 dx with respect to x. Same, okay, what we have done just a bit earlier. First, I will differentiate, okay, what is inside my bracket. So 3x plus 4 differentiated is 3. I divide by 3. Then, next step, negative 4, right, I have to add 1 to it. So if I add 1 to it is negative 3. Then I divide, okay, by my new index, which is negative 3 itself. So I will put down at the denominator negative 3. Don't forget my integration constant. So what I'm left with is negative 1 over 9. Okay, this negative comes from this negative here. Negative 3 times 3 is 9. And then what we have is 3x plus 4 to the power of 3 plus c. Now, part C, for part C, what I'm integrating is, I'm integrating 7 minus 5x to the power of half with respect to x. So, first thing, okay, 7 minus 5x, I differentiate. So, 7 minus 5x, I differentiate, what I will get is negative 5. So, I divide by negative 5. Then, I'll work on the half. Half plus 1 is 3 over 2. So I must divide by 3 over 2. So here, what I have, okay, Then don't forget to add c for my integration constant itself. Okay, so oops, I think I made a mistake. Okay, it's not power half here. Okay, my error here is this. Let me just erase this. My bad. This is negative half. Okay, so never mind. Okay, if this is negative half, okay, what I have here is, let me just erase all of this. So what I have here is, first and foremost, 7 minus 5x to the power of negative half. So differentiating 7 minus 5x, what we get is negative 5. Let's just divide by negative 5. Negative half, okay, plus 1 is positive half. So over here, the index becomes positive half. So I must divide by the new index, this half, adding my constant there. So what I have here is, at my denominator, 7 minus 5x to the power of half. My denominator yields negative 5 over 2 plus c. So 1 divided by negative 5 over 2 gives me negative 2/5. Hence, this will give me negative 2/5 square root of 7 minus 5x plus c. That is part C. Okay, I urge you now to pause the video. Please try 6, okay, and I'll carry on in a short moment. Okay, for part A itself, again, same thing. First, you differentiate 2x minus 9, you get 2. So you divide by 2 here. 4, you add 1 is 5, then you divide by 5 over here. Simplifying will yield this. For part B, you will express 1 over 3x minus 1 cubed as 3x minus 1 to the power of negative 3. So 3x minus 1 differentiated gives you a 3. Negative 3 plus 1 is negative 2. Simplifying, what we'll get here is 1 over 6. Okay, negative 1 over 6, because 3 times negative 2 is negative 6. So negative 1 over 6 times 3x minus 1 squared. So we just express it in positive index form, and we will plunk it down in the denominator. Okay, for part C, you express it as power half here. So differentiating this, you get negative 1/3 over there, the denominator. Half plus 1 is 3 over 2. So you simplify. Here is 3 over 2 times 1 over 3. You get negative half. 1 over negative half, you get negative 2 over here, times 5 minus 3x to the power of 3 over 2. Okay, and that yields try 6. Now, okay, what we have is, why do we integrate? So what are some applications of indefinite integrals? So for example, we may want to find the equation of a curve. So what we may have is the gradient function dy dx. So if we integrate, okay, and if we have sufficient information, we can actually get back the original equation y. Then the rate of change, okay, dy dx, dy dt. Okay, the area between a curve and a line, we will cover that in chapter 17. And displacement, velocity, and acceleration, that is covered in chapter 18 under kinematics itself. So now, example 7, the gradient of a curve at any point is given by this, okay. So now, the curve passes through the point 2 and negative 5. Find equation of the curve. So, what we can do here is this. If I integrate dy dx, okay, with respect to x, what I get is the y itself. So now, what I'm going to do is, I'll write this to get back y. I will attempt to integrate x cubed minus 3x squared with respect to x. What I did here was I simplified this. So now my y is equals to x to the power of 4 divided by 4 minus 3x cubed over 3 plus c. Don't forget this constant plus c. So y is equals to 1/4 x to the power of 4 minus x cubed plus c. Notice that we still have a constant c. How do we find this constant c? They given us this where the x value is 2, the y value is negative 5. So I sub here as negative 5, this as 2, this as 2. If you do all of that, okay, what we get is negative 5 equals to negative 1/4 2 to the power of 4 minus 2 to the power of 3 plus c. My c value in this case is -1. Hence, the equation of the curve is y equals to minus x cubed minus 1. That's example 7. Please attempt try 7, which is vastly similar to example 7. And when you're done, please unpause the video and I'll go through with you try 7. Okay, for try 7, same as what we have did in the previous example. If you integrate dy dx, okay, what you will get is y itself. So same thing, just to recap how to do this. Differentiating 2x minus 1, use the 2, you divide by that. The index was 3 plus 1, so it's 4. You put the 4 right below there. So I get is 1/8 2x minus 1 to the power of 4 plus c, where you need the c, the integration constant. You have 0, when x is 0, y is 3. Substituting it, you get the appropriate c value. So hence the equation of the curve is given by this. Okay, last example for 16.1. Okay, so now a curve for which the second differential 6x minus 16 has 2 points on it. Find the equation of the curve. So notice that now, right, we are at the second differential. So if we differentiate twice to reach the second differential, so it means that we have to integrate twice to get back to the equation of the curve itself. Therefore, okay, first we have I integrate one time, so dy dx will yield, okay, the integration of 6x minus 16 with respect to x. So what we have is 6x squared over 2 minus 16x plus c. So dy dx is equals to 3x squared minus 16x plus c. Okay, don't bother now with the c. There's not much we can do. Why not? Because we do not have dy dx, okay, in this case. So with the c is just that we need to integrate one more time. So if I integrate one more time, okay, y is equals to the integral of 3x squared minus 16x plus c with respect to x. So what I get is 3x cubed over 3. This one you should be expert already. 16x squared over 2 plus, here is something that you have to take note of. C is a number. So if you integrate 8 with respect to x, you get 8x. You integrate, let's say, 20 with respect to x, you will get 20x. So now, if c is a constant, if you integrate c, what do you think you should get? You will get cx. Okay, then now we need another constant. So please, every time you integrate, there will be a constant appearing. So please don't go and put in another plus c here. You're going to confuse yourself. This c and this c are different. Also, please don't go and put c2. All right, you're just making trouble for yourself. So the easy way out of this is cx plus d, where d is what I call another constant. So c was a constant when we integrated the first time. Okay, then this d is another constant when we integrated a second time itself. So now notice we got we simplify. So y is equals to x cubed minus 8x squared plus cx plus d. Oh no, now we got c, we got d. Okay, what do? Notice that we got 0, 3 and -1, 0 there. So now first, okay, I will substitute x equals to 0, y equals to 3 from this point here. What we get is 3 equals to, this simple, 0, 0, 0. My d value is equals to 3. Now, the other point I have is -1 and 0. So when y is 0, my x value is -1. And the d, we know from above, we solve for d equals to 3. If you solve all of that, what you get is that your c value itself will yield -6. Hence, okay, what we get is y equals to x cubed minus 8x squared minus 6x plus 3. And we are done, okay, with example 8. All that is left for you now is to try it, where the second differential use 6x plus 12. If 1, 5, negative 1, 11, find the equation of the curve. I think this one's slightly more difficult. You actually need to, you reach a point whereby you need to use simultaneous equations to solve. Okay, do give it a shot now, try to think through it. I think you have sufficient mathematical knowledge to actually solve this. When you are ready, please unpause the video. Okay, if you integrate, okay, the first time, okay, 6x plus 12, okay, what you get is 3x squared plus 12x plus c, the integration constant. Then you integrate one more time to get back to y. So you get 3x cubed over 3, 12x squared over 2, plus cx, remember what I spoke about, plus d. So you get the equation of curve is y equals to x cubed plus 6x squared plus cx plus d. Now, okay, if you sub in 1 and 5, when x is 1, y is 5, what you get is, over here, c plus d equals to negative 2. Not very helpful. You still have two unknowns, c and d. Similarly, if you substitute x is negative 1, y equals to 11 into this, what you get is d minus c equals to 6. Notice that now what you have is one equation here, c plus d equals to negative 2, and d minus c equals to 6 as equation 2. You solve them simultaneously, you'll find that c is negative 4, d equals to 2. So if we put back into this original equation, y equals to x cubed plus 6x squared minus 4x plus 2. And that is the basics of integration. 16.1 indefinite integrals. Thank you for watching.